So in this video we're going to take a look at meso compounds. So we've been looking at chiral molecules, molecules that contain chiral carbons and their stereoisomers. A meso compound is a compound that is achiral meaning not chiral, due to symmetry. So even though it contains chiral atoms, it is achiral. So if we put it in a polarimeter, it would not rotate plane polarized light. We're going to take a look on the next slide at how that happens and what that looks like. So let's take, for example, this molecule here. Now if we look at this molecule, we have two atoms that have 4 different groups around them, so they would be chiral atoms. So if we look at the atom on the left-hand side, the second carbon, we know that bromine is the heaviest atomic mass. Then we have 2 carbons and an H coming off of that carbon. The carbon to the right has a bromine on it, so that would be number 2, and this methyl would be number 3. I'm going clockwise, and my H is sticking back, so the absolute configuration of that molecule is R. Again, we can assign priorities like we learned in class, and again I have R. So that particular molecule is the RR stereoisomer of this 2,3-dibromobutane. So in order to look at the symmetry of the molecule, what we're going to do is rotate the molecule 180 degrees so that it's in sort of the most symmetrical orientation that it can be. So I'm going to take and rotate 180 degrees around that central C2-C3 bond. And when I do that, the bromine that was sticking out on the right-hand side is now going to be going back because I've gone 180 degrees in the opposite direction. So we can see that our CH3s line up now. So this CH3 lines up with this CH3, but our bromines don't line up. So one bromine is sticking out and the other bromine is going back. So this molecule is not truly symmetrical because you don't have a mirror image right down the middle of it. So this is an example of a molecule that would not be a meso compound. But I want to look at the diastereomer of this molecule. So we looked at RR. On the next slide, we're going to look at RS. So here we have R, and there we have S. So remember 1, 2, 3. Clockwise is R. 1, 2, 3. Looks, I'm going clockwise, but my H is sticking out at me, so it's going to be opposite of what it looks like, so this is S. Now, what I want to do is rotate 180 degrees again so I can look at this molecule. So I'm going to switch colors here. So I rotate about that central bond, and now the bromine that was going back is coming out. And there is a line of symmetry directly through this molecule such that the left-hand side looks exactly like the right-hand side. The H's line up, the bromines line up, and the methyls line up. And when that happens, a compound is meso. So even though this compound has 2 chiral carbons in it, the line of symmetry renders the molecule achiral or not chiral. So in a polarimeter you will see no rotation of light from this compound. And any compound that has a line of symmetry but still has chiral carbons will be achiral, and we call that meso. So we can look at some other diastereomers of one another. So here's a cyclic compound. Here I've got a cyclohexane. It's a 1,3-dimethylcyclohexane. Its diastereomer would have one configuration the same and one different. You can see here that on the left-hand side, in this diastereomer, I have a line of symmetry right down the middle. This is going to be a meso compound. Over here, there's no line of symmetry, okay, because one methyl is going out and one methyl is going back. So this is going to be a chiral molecule. And these two molecules happen to be diastereomers of one another. So when you have molecules that look like they could have symmetry, some of those stereoisomers are going to be meso compounds. And your job will be to find if there is a mirror plane, a plane of symmetry in the molecule that essentially cancels out the chirality of that molecule. So to recap, meso compounds have chiral atoms but are achiral, meaning not chiral, due to symmetry. So looking at an example again, the molecule on the left-hand side has a plane of symmetry. Each side is equivalent to one another. That would be a meso compound. Its diastereomer over here on the left, one is out, one is back. There is no line of symmetry, so they're not mirror images of one another because of the spatial orientation of the groups on the chiral carbons. So that particular diastereomer, stereoisomer of this molecule would be chiral.